Hello. Oh, that was quick. All right. So hello, everyone. If I haven't met you already, my name is Taylor McGrath, and I am currently the VP of Solutions Engineering at Rivery. Happy to be here at SKID again for the second year. And today we're going to talk about the mountains of metadata, specifically as it relates to defining data architecture and building out data infrastructure. And I guess I have to use this. So a little bit about what we'll cover today. I think some of my main points have been touched on a lot today in previous talks. There's a lot being said of late about, kind of these hype cycles of data stacks and data architectures kind of in the industry right now. So we'll talk about how I think we got there, maybe biased opinions there, but overall I think we're in a mindset right now as data professionals where we are very tech first in our thinking, very technology first in our even decision making. When we're thinking about, okay, I have this use case, I go right to what's the stack I'm going to use? What are the pieces of the puzzle I'm going to put together in terms of software and tooling? And yes, this is definitely the stack that should not be named, otherwise known as the modern data stack that we've heard a bit about today already. And I always wonder if the modern data stack is actually really that hyped, or if it's just 3 rooms of SKID-sized people that actually know what it is and are like, it's all the hype, the modern data stack. But to me, it feels very hype in terms of the marketing that we've seen on it for the past few years, et cetera. And then ultimately end with what are some alternatives? What's next for data architecture in terms of how can we realistically get better, right? With the technology options we have today, advancements that have been made in technology, but that also align to data architecture that we're defining as per our data strategy, business strategy, a la the last few presentations that went deeper into that. So to get started with how we got here, and I'll start with kind of when I entered the scene of data, which admittedly is after some of the people here. I started around 2013, 2014 as a BI analyst, but maybe today would be called an analytics engineer in reality, at a big bank. And I think very popular things at that time were big data, data science, moving to the cloud. These were the buzzwords. And a few years after that was the first time I really heard of truly real workloads moving to the cloud to kind of meet the data where it's at now that we have more and more data in the cloud because more applications are being built there. And that's when I first heard of Snowflake, and maybe this is a biased opinion, but I think a lot of the modern data stack is because of Snowflake and Snowflake's rise. There were this, advanced technology that was separating storage and compute, fully managed in the cloud, and was super easy in multiple ways. Super easy developer experience to get started, the UX of Snowflake, and super easy to get started budget-wise as well, right? The concept of paying just for what you use. And this took off like a rocket ship, and not only the tech took off like a rocket ship and the adoption, but the following and hype of Snowflake as a company took off. And so naturally, there were all these other companies that formed and were like, we want to be the Snowflake of ingestion. We want to be the Snowflake of yada yada. And it became where every feature or functionality that we do with data became its own category of tooling, that we're the Snowflake of XYZ category. And so because we could now bring workloads to the data, this really fueled doing ELT over ETL. ELT was all the rage now that we had the tech to transform data where it's at in the cloud, using these types of softwares. And this combination of point solutions that were built around cloud data warehouses became known as the modern data stack, right? And so the idea is the barrier to entry, super low, both for my developers to get started. Maybe I don't have the skill sets of heavy duty engineers in my growing company, but I still need to answer some questions, still need to put together some sort of data infrastructure to get things into a centralized location and build insights off of that. And so, this led to a mindset shift of like these companies are the exciting thing to follow. The technology is cool, and like this type of graphic became like super popular to see. And even today, I talk like so many businesses that we've talked to when we're asking about their current state, data architecture, or currently, what is their current use cases they're working on, their pains. They'll show us something like this, and they'll be like, well, we're using like Fivetran to do this and this and this, and it's all technology. And just looking at this, I can't tell you a thing about the company. Like, I can't tell you a thing about what they're doing value-wise, even a business use case. Like, I have no idea. Like, that's just a stack of tech, of software. But I will say that there's plenty of good that came from this era. I think there were technology advancements that really, like, there's good parts about things being easier to use, right? Like, we have this goal, or maybe it's a pipe dream of democratizing access to data, and I think this moved like technology in the right direction, but it shifted our mindset, and I think it was Chris or Matt in the last one that was talking about engineering over architecting. Like, I think that's exactly what happened here. And so I'll talk a little bit about the specific shortcomings that come up when we're thinking of things technology first. And first, we'll go to, I guess, our depiction of the modern data stack. So really, when we're thinking about all the source systems that our data lives in and centering it around a data warehouse, and then ultimately the consumption that happens after the fact, really this like tooling ecosystem around a data warehouse, this like, spider web, spaghetti string, whatever you want to call those, of each one of those little circles is a software, let's say, that's doing ingestion, that's doing transformation, that's doing some sort of monitoring, observability. Like, all of these things are their own like mini ecosystem, and they have metadata, and sometimes that's hidden or exposed. Some tools expose all their metadata, some tools are more closed. And so if I want to see the full picture of what's happening, I have to connect all of these dots, and that's a time cost. And some of them you're not even able to connect. And so it like creates these kind of unseen gaps in what's happening in my data infrastructure. And this is a nice ode to the city I just moved to. So yeah, passive aggressively mind the gap there. And so in addition to having all these like hidden gaps, we also have for each one of these tools like almost a tribe or gatekeeper of knowledge around the softwares of like who is the expert or the hero, I think was said in a prior talk, of XYZ technologies. And so if a stakeholder could benefit from one of these technologies, they have to go through hoops of whatever gatekeeper, getting skilled up on that technology, and all of that, is a time cost as well. And in addition to the issue, like the issues we've had, or not issues, but the challenges that we've had with, even starting with big data, you think of like the 3 V's, right, of volume, velocity, variety, and all this changing, and taking that into account when we are defining our data architecture so we can be agile around these things when things naturally change in our business. Now data teams actually own more types of use cases than they used to because of the advancement in tech. Like, who's familiar with like reverse ETL as a term, what that is, right? Like, reverse ETL means I'm taking data from my warehouse that maybe already has business logic built in, and I'm sending that back to a source application. Like, that didn't really used to exist, and when it did exist, it was not in from a cloud data warehouse, so it was not owned by the data team. Like, that was an operational use case, like shadow IT maybe, right? So now data teams not only have your traditional use cases to manage like your reporting, your analytics, but they're stepping into other facets of operational use cases, ML, AI, etc. So there's like these time costs add up, and it becomes that like the sum is not greater than the parts, right? Like, all these things we're putting together, the value we're getting out of it is not greater than the maintenance costs, the understanding the actual cost of these softwares and differing pricing models and monitoring it, like in terms of these FinOps disasters that you hear about, of all these technology stacks. So what's better though? Like I think we can agree on like certain shortcomings, agree or disagree, but I think naturally what I've seen today, even from all of these talks, is that there's general alignment that this is the state of the world right now in terms of there being a gazillion tech options to choose from, and we're kind of over-engineering things. Tech people like the tech, and we're not doing things in a best practice manner to standards, to governance, et cetera, and thinking of our data strategy and ultimately our business strategy first. So what's better? So in terms of, or actually, first let me set the stage. I'm going to talk about two different scenarios, and it's really simplistic, way more simplistic than the team topologies talk. But really, like, if I had to bucket types of data teams in today's world into two types, there's the traditional, like, centralized data team that are kind of owning end-to-end data processes. So from the point of ingestion to delivering data assets, at smaller companies, these teams might own the BI and reporting as well. To now, we're starting to see, since like the kind of data mesh paradigm shift of let's have the domains own their end-to-end data products and be powered by a data platform team to set the governance, to set the standards, to enable them, et cetera. So naturally, if we have a different operating model and that's part of our data strategy, then it may make sense to think about our architecture in a different way, because we may have a different bottom line, so to speak, in terms of adhering to the architecture we've defined. So again, the visual from before with the modern data stack, and then what could this look like realistically in a better sense? And so I think for me, this whole clutter in the middle of all these tools is kind of the core focus and the core thing we can bring back to standard components, back to fundamentals, right? So decluttering with like a minimalistic mindset of like, hey, our the outputs that we need, the deliveries that we need for XYZ use cases require these standard components, these standard functionalities. And so when we eventually think of technology, because we do need technology accelerates what we do when we use it correctly. So when we're thinking of how we're going to actually build our infrastructure, to treat it with a mindset of, minimalistic architecture at first, the building blocks, right? The building blocks that adhere to the best practices that we've defined. So what does this actually mean in terms of value? If I have fewer tools to set up and integrate and maintain, that's first a reduction of costs and a reduction of time costs in between those gaps, integrating tooling together. There's this concept of context switching. So if I'm in maybe a really easy to use platform, a couple clicks for ingestion, and then I go to my like very code heavy transformation tool, and this is my stack, then there's like this switch of context that I continually have to go through in my human brain to kind of switch the mentality that I'm of the system I'm working in. And in terms of being able to do an end-to-end use case in one place, and I think when we got into data mesh and the team topologies example, I'm talking about a self-service data platform where essentially there's one unified interface for kind of building and delivering data products. We get the advantage of doing all this in place and being able to templatize. So that could mean creating, standard configurations for types of use cases in one department or one domain and sharing that across other domains. And that's something that, the data platform team can own. So there's additional efficiencies that can be had when all this is in one unified place. And so, if we're going back to platform, the platformization of the world. So back before the modern data stack, when we had these like legacy data platforms like Informatica, et cetera. Unlike those, what we now have with the cloud is this concept that they can be like closed but open, right? So this modularity, optionality of, yes, I'm doing everything in one place, but because we're in the cloud and we can share metadata across APIs, et cetera, that we actually, can swap out different components if that's something that will, accelerate our time to value to our business. And so going back to the two different teams or types of data teams, like what about the decentralized use case? Like what about if we're trying to do data mesh, or at least trying to go more hybrid in the direction of decentralization, because jumping straight to full data mesh is hard and probably impossible. And so what if we're trying to just start with a data platform team that serves other downstream teams? Like what does that look like, and what is the data architecture that would be needed to address this data strategy or this operating model? And so what's important, I think, is to like define the components that absolutely need to be centralized. So when we're thinking of security, when we're thinking of compliance, we're thinking of monitoring the platform as a whole in terms of usage, et cetera. What are the things that a data platform team should own because they're across the whole platform, versus the freedom that we want to give our downstream teams, our domain teams, to self-serve. And so it's an understanding of like where that line lives that I think is important, and also an understanding of, is it going to change in the future? So if we, again, can align it back up to our data strategy of where we want to be in 2-3 years down the road, and that can determine how flexible the infrastructure we build needs to be to change. So, yeah, operating model, this is kind of what I just said. So for example, if we want to centralize things like standards, compliance, governance, et cetera, the idea is then I can create, based on where my line is here, the idea is that I can create and curate these like governed areas where all the central components exist in terms of standards, governance, but there is still that unified place, interface, where domain teams can operate, where they can go from A to Z to actually create a data product and have that feedback loop wildly decrease. So in kind of the traditional example, there's like a business use case, a request goes to the data team does it, delivers it. And so that whole feedback loop includes waiting for the data team to do it, right? Whereas with a more decentralized model, and I think what data mesh aims to answer is that you no longer need that data team in that feedback loop. The feedback loop exists in the domain team. And so instead of weeks, months to delivery, it's days. So a little bit about Rivery. And if we're talking about first fundamentals of data operations or ELT, let's say, we have one, we need to get data into some centralized place, be able to transform it there, be able to orchestrate these processes, automate downstream things to happen all in one place, but with the interoperability of the bring your own, the closed but open concept. So Rivery has a bunch of native connectors as well as streaming options with CDC, the ability to easily create your own custom connectors, leverage push-down SQL, or leverage an existing industry-wide tool like dbt, as well as automate all of these and call out other processes to happen downstream. So kicking off an extract to happen in our BI tool, or a Slack message, for example. And then, in addition to just the base functionality, the things that make it a platform. So the things that are that give us the ability to create these governed environments where we can standardize things across the whole platform. Role-based access control, for example, I can decide in which workspace people can do what, so that I know exactly the things they can connect to, where they can land data, but they have the freedom to do all of this, right? Once we set this up. And again, with because you can do end-to-end use cases all in one place, you can essentially leverage or create even an internal marketplace for your organization of an end-to-end use case or template to share across your organization and speed up that time to value even further. And I think that was pretty quick, but that's what I have for you guys today.